Hello, Python Padawans. We're getting started with the first lecture in Unit 1-2, and this is over writing simple programs or basic Python programs that include a main function or main with left-right parentheses around it. We're going to talk about how to do that, how to structure them, and then we'll give plenty of examples, and some of the examples from the textbook and some that are not from the textbook, and we'll get you started so you can move along into this next module. So let's go ahead and get started. So first of all, Python programs all include commands, but those commands need to be organized into functions. The reason why we do that is so that we can use a single word or a single command to start a very complex sequence of commands, our programs. We want to be able to write Python statements and programs that can assign values to variables, that can get information entered from the keyboard into a variable, maybe assign them to a variable. Some of the things that you practiced last week, or the first week in Unit 1-1, were prompting the user for values and then maybe manipulating those values in some way to using an algorithm to come up with a result, then displaying the result. Sometimes those results are characters like strings, letters, numbers in combination. Sometimes they're numeric, and we'll look at examples of both of those. And we also want to be able to display things to the screen. In fact, the process of writing a program is almost always present the user with a prompt, accept information from the user, display a result, and then in a cycle again and again and again. If you think about how you interact with computers, that's pretty much how it works, right? They prompt you for something, like you walk up to the ATM and you insert your card. It reads data from your card. That's you entering in data. It processes that data and it outputs a result. Maybe it prompts you for a password. You enter in your password. It processes your password, outputs your result. Input, process, output. Input, process, output. You'll find that that cycle is used again and again in your programs. And specifically, we want to be able to do something like perform a definite loop. And in our next lecture, we're going to talk about looping, that process of going through input, process, output over and over again. We'll get to that in the second lecture in this unit, but we need to get this basic information down. So when we develop software, the software development cycle really starts with analyzing what our problem is. If you're looking at a code lab assignment, a homework exercise, you need to really think about what they're asking you to do. Are they asking you to display something specific? Are they asking you to retrieve information from the user? And then determine what those specifications are. If you're supposed to output something, is there a very specific format? Commas, no commas, capital, lowercase, anything like that? And are they specifying variable names? That's always key. If they specify variable names, that we match them. As you go forward and work on programming exercise 1-2 and lab 1-2, we provide you with a problem analysis, but you need to make sure you read it and understand it. And then we provide you with the specifications, and again, you need to make sure you follow them very carefully. Then it's up to you. Create a design. Use your pseudocode to plan out the process that you're going to use to solve the problem. Then write the Python commands that go inside the design. Then test your program. If it doesn't do exactly what you need, go back and reanalyze the problem, determine the specifications, make sure you're meeting them, maybe modify your design to better meet the specifications, type the Python code in, test it, and it is definitely a cycle. It's circular. You're going to go through this again and again as you work your way through. So each of these stages gets modified depending on what you produce in the previous stage. All right, so we analyze it. Make sure you understand as much as you can about the problem. Very important that we do that. We make sure we understand exactly what the program's supposed to do. And we don't worry about how it's going to do it, just we want to make sure we understand what it's supposed to do. We make sure we talk about the inputs and outputs and how they relate to each other. And we also want to talk about how we're going to solve the problem by writing the algorithm, the how the program is going to solve the problem, get that written and tested and make sure that it's working correctly. We may very well want to develop our own algorithm. You know, if you're supposed to just calculate the length of the hypotenuse of a triangle, there's several formulas for doing that, from Pythagorean theorem to other theorems and other formulas for calculating that value. But Maybe you have your own unique way to accurately solve that problem. Fine, develop your own algorithm if you need to. And sometimes there's no pre-existing algorithm to solve the problem. We have to think through and analyze the problem and come up with that algorithm ourselves. Then we actually type the code into our program. We use our Python code, and we usually insert that code in between each of our pseudocode statements so it makes sense. And then you run your program and make sure that it's working correctly. You want to try it, right? You want to test it. In fact, you want to try to break it. You want to enter in values that are unexpected and just see what your program does. If there's any problems, your testing process should be able to solve those, and you'll be able to debug your program. And again, you definitely want to find all those errors if you can. So try to break your program. Trust me, you're not going to hurt anything. You're just going to have program's going to stop running. You'll see where the holes are in your logic. You'll find maybe things that you can do to resolve them or to make your program more bulletproof. So work on that. And then finally, we have maintenance, right? Even if a program works perfectly, over time, our needs can change, or we might want additional features. And something you're going to do this semester is a semester project, and you'll see that posted coming up this week. And the next week, I should say, in Unit 1-2, you'll see some announcements for the semester project. And in the semester project, you're going to develop the first milestone here in Module 1, and then you're going to modify and maintain and expand that program through each milestone, 1, 2, and 3, and 4, as you develop an overall program for the semester. And that's a great example of writing a program that solves a problem and then being given a more expansive problem. You need to maintain your program to make sure it satisfies the next needs. In the real world, programs are never done. There's always something. I mean, how often has your phone told you, hey, I just updated to the new operating system, and you thought to yourself, it was working fine before? Well, there's constantly some sort of maintenance and upkeep happening to programs as they evolve over time. Let's talk about a temperature converter. So a program that accepts a value in Celsius and wants to convert it to Fahrenheit. So it's very straightforward, right? Prompt the user for a temperature in Celsius, 0, and then run through and convert that to Fahrenheit and display the result. Well, if you just know the math, 0 in Celsius is 32 in Fahrenheit, right? And 212 in Fahrenheit is 100 in Celsius. But that's not the math algorithm, right? There's a mathematical formula that actually comes up with that result. The specifications of the program are pretty simple. I have an input in Celsius, I have an output in Fahrenheit. So we've got that part right, and we can look up the formula for converting Celsius to Fahrenheit. It happens to be 9/5 the Celsius value plus 32. So if Celsius is 0, 9/5 times 0 is 0, plus 32 is 32. And if the Celsius is 100, 9/5 plus 32 turns out to be 212. So we've got that figured out. That's our formula. We can go look that up, right? We've got we've got Google, we've got other sources, we've got math formula textbooks or whatever tool we need, or maybe you just know that formula in your head. I have to say that in my head, when I convert from Celsius to Fahrenheit, I just double Celsius and add 32. I know I'm plus or minus a few degrees, pretty close. But when someone says it's 32 degrees in Celsius, I know for a fact that that's hot, because 32 times 2 is 64, plus 32 is 96 degrees. It's warm. So that's how I do it. But hey, the exact formula, of course, is 9/5 Celsius plus 32. And we want to use that in our program. We can plan our program out with pseudocode comments and then enter in all of the commands. So my pseudocode might be, for example, first prompt the user for the input in Celsius, then convert to Fahrenheit using the formula, Fahrenheit equals 9/5 Celsius plus 32, and then finally output the results to the screen. So if these are the comments for my program, right? This is not the Python commands. I would then add an extra blank line between each set of comments so that I can enter in my actual code when I do the actual program. So I didn't have enough room on the screen here to show everything, but that first comment, prompt the user for the input in Celsius, would be displayed right here above this one. Then convert it to Fahrenheit using this formula would be displayed right above this. And finally, output output the results to the screen would be right here above the print statement. Maybe we want to correct our output to just a few decimal places because the math we're doing 9/5 times Celsius plus 32. I might get something with a lot of repeating decimal places or something like that. So I want to be careful about that. You know, what if the input temperature wasn't a whole number? What if Celsius was input as, with a fraction? And then when I do 9/5 plus 32, I get something with a lot of decimal places. Perhaps I need to do something with Fahrenheit to control it down to a couple of decimal places. We could talk about that a little later, but when we test our program, we can see how it works. When we run it in testing it, it prompts the user, you type in a value, it does the math. Notice I typed in an integer, no decimal places, but I got decimal places as the output. As we talk about in this unit, we're going to talk about computing with numbers, and we'll talk about the differences between integers and float values, values with decimal places, or integers, values with no decimal places, no fractions. You will notice that if we do something like 9/5 like this, we're going to get a float value as a result. So it did 9/5 times 0 and got 0.0 that added 32. Something similar happens here. These are, by the way, 3 interesting checkpoints that we can use to make sure our formulas are correct, because negative 40 Celsius is negative 40 Fahrenheit, 100 Celsius is 212 Fahrenheit, and 0 Celsius is 32 Fahrenheit. We can make sure our program is working correctly if we know some of the output values ahead of time, or even if you just manually calculated them. You want to test your program and make sure you're getting the right results. All right, so you've been asked, let's say you've been asked to write a program that calculates the future value of an investment based on a fixed interest rate of 3.5%. Now, you don't need to know the math formula to calculate the future value of an investment for this problem. Just think through the analysis and design portion of this. You want to display a description of the program, prompt the user to provide the number of years and the investment amount. So write the pseudocode for this. Take the time, you might even pause this video, take the time to write out the pseudocode to solve this problem. Now, you've been given the specifications, and maybe you haven't been given the specifications for how many decimal places you should display, but if it's an investment in money, it probably only has 2 decimal places, right? So you can figure that part out. But if you could go look up, you can go look up the future value formula. But we're not asking you to do that right now. What if you just wrote the pseudocode? This would be similar to the pseudocode here, right? If we convert from Celsius to Fahrenheit, it's prompt the user for the value, use the formula to calculate the result. If we know the formula, great. If we don't, just in your pseudocode, use the formula to calculate the value, display the result. That's what we want to do here. And it's pretty much the same 3 steps. So you should have come up with something that looks like this. Describe your program's function, and in this case, it says display a description of the program. Part of the specifications were to display a description of the program. So display the program's function, prompt the user for the number of years and the investment amount. That's 2 inputs, right? 3.5% is the interest rate, the investment amount, and how long I'm going to invest. Calculate future value at 3.5% interest. I don't need to know that formula yet. I'm just writing my plan here. I can go look up that formula. It's available somewhere on the internet. And then finally display the result. This process of writing the pseudocode for each component of your program, you need to get used to this. Do it every single time. Do it when you're working on CodeLab. Don't just start typing Python commands. Type out the pseudocode for how to solve the problem first, and then type the Python command. I can't tell you how many times I've had a student come to me and say, I'm working on CodeLab homework number, whatever it is, and I'm struggling, I can't make it work. And I go look at their program, and there's no pseudocode. They don't have any plan whatsoever. They just started typing Python commands, and they're struggling. But if they'd taken a step back and thought through what they were typing, they would at least have a plan. It's the same thing when you're working on your programming exercises and your lab assignments. If you come to us for help and you have your Python program typed out and there's no pseudocode, no plan, nothing, one of the first things we're going to do is ask you to go back and write out the plan. And many times that process of writing out the pseudocode plan, the design, solves the problem for you because you realize, oh, I skipped a step, or I'm doing these steps in the wrong order, or whatever it is. So do this first, always, every single time. Plan it out with a design in pseudocode. All right, so a little review here. Every identifier or variable must begin with a letter or an underscore followed by a sequence of letters, digits, or underscores. They cannot start with a number. Also, they're case sensitive, and this is important. So capital X is a different variable than lowercase x. Capital C, Celsius, is different than lowercase. Doesn't matter where the capital letters are, that sort of thing. Those are all case sensitive. So be very careful when you're writing your identifiers. Don't overuse them. And you try to use something that makes sense, right? Instead of just X, Y, and Z. If those are not coordinates on a chart or a graph, don't use X, Y, Z. Use things like real names, like name, age, birth, class, grade, anything like that. Some identifiers are reserved words, and you'll always know because when you type them into your Python program, they will change colors to a lavender or maroon color, a light red color, that shows you that's a reserved word. Don't use those identifiers for variables. There is a table in your textbook, I believe it's on page 32, but it's table 2.1 in chapter 2, and it shows a lot of the reserved words. Don't use those for variables. For identifiers, just reserve those. Use something else. So if you start typing in a variable name or an identifier name and it changes color for you, that's telling you that that actually is a reserved word. Don't use it. We also then use operators to create expressions. So if I want to add the values of x and y, x plus y, the plus is an operator. So is minus and multiply. The forward slash, now there are 2 slashes on your keyboard. Careful, the forward slash is the one on the question mark key. That's divided by, and then double asterisk is exponentiation, so squared, cubed, that sort of thing. There is no operator for root values, like the square root, the cubed root, or the fifth root, but instead what you can use is fractions. So if you use exponents like this, and then in parentheses afterwards, you would put like 1/2. That would be the square root. So that's one of the simplest ways to get root values. But operators allow us to build a full expression. We also don't really care about spaces within an expression. So 1 space plus space 2 is the same expression as 1 plus 2. So spaces and tabs, those sort of things are pretty much ignored. You just use them to make the most sense, to make it easiest to read. And of course, mathematical precedence is important, right? Parentheses first, then exponentiation, multiplication, division is next, and addition, subtraction is last. And if you have 2 or 3 in a row, then it's left to right, right? So if you have 5 times 2 divided by 4, it's going to do the 5 times 2 first, not the 2 divided by 4 first. So that's going to be a part of it. Or we use parentheses to control it. So first thing we do is do this evaluation, and then finally this evaluation, then this evaluation, actually exponent first, and then this evaluation, and then add the 2 results together. So parentheses are a way to control it. When in doubt, if you're not sure what's going to happen first, use parentheses. I always do. I use parentheses even if I know 2 operations are going to happen first. I put parentheses around them just to make sure they happen first. It's always best. If you're not getting the results you think you should get, you probably have an order of operations error somewhere. So an output statement, a print statement, can show any number of expressions. You can separate them by commas. And more than one print statement shows on separate lines. Basically, if you use a print statement, print parentheses something, it's going to add a new line character to the end. It's like pressing enter on the keyboard. So every time you use print, it's going to add a new line, a separate line on the screen. You can even just use print and left-right parentheses with nothing in there, and it'll just print a blank line for you. So that's helpful when you're laying out your output. So if I did print 3 plus 4, I would get 7. Print 3, 4, 3 plus 4, it's going to print 3, 4, And 7, in an earlier lecture, I had talked about how this comma adds a space between the output values. Print by itself is a blank line. We can tell the print statement not to add a new line character on the end. So if I do print 3 comma 4 comma end is a space, it's going to do 3 space 4 space and then wait, and then the next thing I print, which happens to be 3 plus 4, will end up on the same line. So you can do this at 2 separate print statements even to get something all on one line, or you could say print the answer is comma 3 plus 4, and it'll put them all together. It's a little bit of a review from last week's lectures, or Unit 1 lectures, Unit 1 lectures, but even so, it's a nice little reminder of how those print statements work. A little review here just very quickly on assignment statements. Remember that assigning a value is taking an expression, which is the right side of the equal sign, evaluating that, and then storing or assigning the results to a variable. The equal sign here is not an equal sign. It is an assign operator. It assigns this result to that variable. So this result is assigned to X, or this result is assigned to Fahrenheit, or 5 is assigned to X. So we can simultaneously assign 2 variables. So I could say sum, comma difference, that these are the variables on the left side, are assigned this value and this value. So the sum of X and Y is assigned to sum. The difference between them is assigned to diff. I can do that. And I can even use that, and this is something that we did in the first homework assignment. If I have X equals Y and then Y equals X, I can't get them to swap values this way, because whatever was assigned to X gets overwritten by Y. Now they're just equal. If there were 2 separate values, we could do them this way: X comma Y equals, evaluate them on this side. So whatever's in Y gets pushed here, and whatever's in X gets pushed here. This is a way to simultaneously flip-flop or exchange values between 2 variables. So how about inputting multiple variables from a single statement? So I've defined something, and I've got spam comma eggs equals input, evaluate the input, enter the number of slices of spam followed by the number of eggs, and then print a result. So when I run it, I get, here's my prompt. This is the prompt. If I type in 3 comma 2, they're separated and stored into spam and eggs. So when I print it, you ordered this many eggs and this much slices of spam. And so the result looks like this. 3 goes into spam, 2 goes into eggs, and my output is 2 eggs and 3 slices of spam. So I can do that as well. It's not very commonly done because it does require the user to actually know to put a comma between the values, but it could be done that way. All right, so let's run through a few of these. Which of these are valid or invalid? So let's say X exists, and I said X equals 5 plus X. Is that valid or invalid? Well, it's valid because if X already has a value, I'm just going to add 5 to the value and reassign it back to X. In other words, I'm going to increase X by 5. What if X wasn't defined yet? Well, then this would give me an error message. It would say, when it tried to evaluate this side of the equation, that X doesn't exist. But we'll just assume that it does. How about in this one? Capital Y plus equals X. So here I've assigned itself the X variable plus 5 back to X. Here, what's this plus equals? Well, this is a shorthand way of saying the original variable plus whatever I have on this side. So this is the same as saying Y equals Y plus X. So increase Y by X. How about 5 equals X plus 2? I can't assign a value to a number, and a number cannot be a variable by itself. I can have a variable called X5, but I can't have a variable that starts with a number. So this is an invalid statement completely. How about this one? Z equals Y divided by 2 over 1 cubed. So 2 over 1 is 2. Cubed is 8. So Y divided by 8 gets assigned to Z. That makes sense. And then how about this? Now, this doesn't have an assignment, but this says statements or expressions. Is this a valid expression? So, and then the question is, what is it? Well, exponents first, right? So 2 cubed becomes 8. 7 times 8, and then double backslash or double slash 4. Well, if you look through, and we'll talk about this in computing with numbers, the operators, though, in chapter 3 that talk about, and chapter 2 and 3 that talk about working with these operators like addition, subtraction, and multiplication and division. There's a special division, there's 2 of them actually. This one's called integer division. So instead of like my 9/5 conversion for Celsius to Fahrenheit, if it was 9/5, it would not give me a float result, it would give me an integer result. So this number, /4, means divide it, but give me an integer result. So this is 8, right? 7 times 8, 56, divide by 4, but give me an integer as a result. So 56 divided by 4 is 14, I think, because 4 into 40 is 10, and then there's 16 more, and 10 and 4 is 14, right? So yeah, so I should get something like 14 as a result, but I should get an integer result, not a float result. All right, so in our programs, we'll define this function called main. And a lot of programming languages actually require a main function. C is a good example, Java, but Python doesn't require it. However, it's very good practice to go ahead and use a main function or define a main function. And most of the time, we're gonna tell you to include a main function in your program. It follows any kind of syntax of functions, and we'll talk a lot more about functions a little bit later this semester. But for now, we're just going to always define a function called main, and all of our commands go inside the main function. Down here at the bottom is a good example. Def is my define statement, so def main, and then there's a colon. You'll find in Python, whenever there's a colon, everything underneath it should be indented. That's how Python knows that these commands go along with this one. So define a function called main, and everything indented below it is a part of the main function. In the main function, I'm just going to print hello world. That's it. Now, when I try to execute this, I need to type in main, left, right, parentheses. It'll call the main function, and whatever commands are in that function all get executed. So here I've defined the main function. It has print hello world. Here I've called the main function. And when I do call the main function, it just executes the statement. It just displays hello world. That's it. That's all that happens. So my program, my main function gets executed, it runs all the commands in it, and it stops, and that's the end of it. As I said, generally we're going to tell you that we always want a main function. There'll be a few exceptions this semester, but we'll be pretty specific and say you don't need a main function this time. But usually you do. So just assume you do unless you're told otherwise. All of the code in your program should be inside the main function. There shouldn't be any code except for like a function definition on the left margin, or maybe a comment, a pseudocode comment. Everything should be inside a function, in this case, inside the main function. Here's my example of my main function that does my temperature conversion. First define main, then evaluate the input from the user, that's the degrees in Celsius, run my math formula to convert it to Fahrenheit, and then finally print degrees Fahrenheit. Notice I've modified my variable names to be a little more specific. This is degrees Celsius, degrees Fahrenheit, and print degrees Fahrenheit. So when I run the main function, it executes all these statements. Here's a benefit. I don't have to run an entire program. I can refer to these statements with just one single command. Anytime I type main, it's going to run these statements. So by defining a function like this, it allows us to more simply recall our program very easily. All right, that's it for today. I should say that's it for this particular lecture. You want to go ahead and watch those, but otherwise, have a great day. Code on, Python Padawans.